students, how are you? I hope you all are doing well. One scientist once said, I am doing research when I don't know what I am doing. That means, if you don't know something doing, that is only research. So, today in this video, we'll do some research. What you don't know. Let us start. Previous video, I explained regarding the Ohm's law and its experimental verification. Today, what I am going to explain, it is about ohmic and non-ohmic conductors, factors affecting the resistance or the factors affecting the resistances, and the specific resistance or resistivity. So last classes I explained experimentally Ohm's law and its verification. Ohmic conductor means the conductor or the conductors which obey Ohm's law are called ohmic conductors. For example, your aluminium, silver, copper, all metals are ohmic conductors, except that I can say that nichrome, copper sulfate solution, with copper electrodes, or I can say that sulfuric acid, all comes under ohmic conductors. By taking the values of V and I, if I draw a graph, the graph will be like this way. It will be a straight line. So I can say that the conductors which obey Ohm's law, they are called ohmic conductors, or we can say ohmic resistors also. So all these things what I mentioned, all metals, it may be nichrome, it may be copper sulfate solution, it may be sulfuric acids, all are examples of ohmic conductors. In this case, if I draw the graph between voltage and current, the graph will be a straight line. That means all these materials, they are obeying Ohm's law. Next one, what is non-ohmic conductors? The conductors which do not obey Ohm's law, they are called the non-ohmic conductors. For example, your electrolyte, your electric bulb filament, junction diode, see that, filament, diode, electrolyte, these are examples of some of the non-ohmic conductors. In this case, if I draw a graph between potential difference and the current, the graph will not be a straight line. Listen carefully. Suppose this is the current, this is the voltage or potential difference. In this case, the graph will not be a straight line. The graph will be a curved line. Suppose I want to find the resistance at a corresponding point at any potential difference or current. I can calculate by taking the slope of the tangent drawn at that corresponding voltage or current. For example, see that I draw one tangent. I want to find the resistance at this point. So at this point I have drawn one tangent. You can join like this one. So here to here, this represents delta I, and here to here it represents delta P. So we can calculate the resistance by taking the slope of the tangent line. And in this case, it is not necessary that the graph will go through the origin. The graph may not go through the origin, and in this case you will find that for different values of voltage and current, the resistance will be different. But in the previous matter where I said the ohmic conductor, if you take the different values of V and I, it does not matter, all the time R will be constant. But in this case, the value of R will be different for different values of potential difference and also for current. Okay, children? Let us go to the second important point, that is the factors affecting resistance. Factors affecting resistance. So, what are the factors? First I shall mention here. One is material. Second one is length. Third one is thickness, or you can say area of cross section. Okay, so material, length, thickness. One more important point, that is the temperature. So let us try to understand through small activity. See here, in this simple electric circuit, P and Q, two free ends. I want to explain the material or nature of the materials. So, in this case, now I shall take conductors of different material. For example, you take aluminium, you take copper. Suppose the length I have taken L, diameter I have taken D. Here also length I am taking L, diameter I am taking D. That means I am taking same dimensions. Both cases lengths are L, diameter I have taken D. In place of diameter, if you want, you can take also area of a cross section, does not matter. For example, I am taking area of cross section A, here also area of a cross section A. I have taken two different materials. Now you connect between the points P and Q. The first one aluminium. Suppose after connecting you record the temperature, you record the current through the ammeter which is connected in this series. For example, you got current is 2 ampere. Now you remove the aluminium. In place of aluminium, you connect the copper between the two free ends P and Q. Again you note down the current from the ammeter. Suppose this time you got current is 2 point, or you can say current is 3 ampere. In case of aluminium, we got the current is 2 ampere. In case of copper, we got the current of 3 ampere. That means when we are connecting the copper, we are getting current more. That means the resistance of copper is less than the resistance of aluminium. How it became possible? It became possible due to difference in nature of the material. Both I have taken the length same, area cross section same, that means a dimension same, and at the same time I have taken two different materials, but I found that in case of the copper, current is coming more, that means resistance is less, and the resistance of aluminium is more in comparison with the copper. That means the resistance depends upon the nature of the material. What we analyzed from this fact? We analyzed that different metals or the different conductors contain different number of electrons, or I can say that the concentration of electrons are different in different materials. Concentration of electrons are different in different materials. That means the number of electrons per unit volume is different for different materials. If the number of electrons will be changed, definitely number of collisions will also change. Suppose in case of the aluminium in compared with the copper, number of free electrons here less in comparison with the copper. Depending upon the number of electrons per unit volume, the conductivity will be decided. So in this case we found that nature of the material is one of the factor which decides the resistance of the conductor. Now we took the same dimensions, but the metals what we have taken here different. Their nature is different. So nature of the materials decides the resistance of the conductor, or you can say resistance of the resistor. Second point, length. Now we'll take manganese. It is one of the standard resistor which is made out of manganese, copper and nickel. It is made out of manganese, copper and nickel. Why I am taking here manganese? Because its resistance is least affected by temperature. One factor is that temperature is a factor. Resistance depends upon the temperature, no doubt at all. But in case of some standard resistors like the manganese, like the Constantine, where the resistance affected least. So suppose I have taken manganese of length L and 2L, and here is the area cross section A. Here is the area of cross section A. Both cases, both are the manganese. This is also manganese. Length L, area of cross section A. Length 2L, area of cross section A. I have taken same material, same thickness or area of cross section, but different length. Now I shall connect this first resistor between the 2 points, 3 points or the free ends P and Q, and I shall record the current through this ammeter reading. For example, in this case you got the current is 2 ampere. Now remove the first resistor. In case of that, you connect the second resistor between the two free ends P and Q, and on the switch allow the current and observe the current through the ammeter. In the second case, suppose we got the current is 1 ampere. That means the resistance in the second case more than the resistance in the first case. What is the reason? The reason is that length of the resistors changed. In the second case, length of the resistor twice the length of the resistors of the first case. Material same. Thickness of the diameter or area of cross section, what you can say, that is also same. The difference is the length. Then what is the reason? The reason is that when the length of the conductor increases, the number of collisions between the charged particles increases, or you can say the number of collisions between the electrons and mostly between the electrons and the positive ions increased. So when the collisions increase, obstruction increases, or we say that resistance increases. So I can say that length is a factor which decides the resistance of a conductor. So previously I said that material, now I said that length. So I can say that resistance is directly proportional to length of the conductor. Okay children, now let us go to the third factor, that is the thickness. Now same manganese I am taking in both cases. I am taking the length as constant L, but in the first case I am taking area of cross section A, but in the second case I am taking area of cross section 2A. I double the thickness. I kept constant the material and the length, just I double the area of cross section or thickness, or I change the area of cross section or thickness. Now like the previous case, you do the same thing. Connect the first resistor between the points P and Q on the switch and observe the reading of the current from the ammeter. For example, you got the 5 ampere current when you connected this one. Now off the switch, remove the first resistor, thereafter you connect the second resistor, and again on the switch and observe the current through the ammeter. For example, you got the current is 10 ampere. What does it mean? It means that second case resistance decreased. Current increased means resistance decreased, because resistance and current are inversely proportional. So here the current increased means resistance decreased. The reason is that thickness is different. When the thickness is more, resistance will be less or current will be more. So I can say that resistance is inversely proportional to area of a cross section. Resistance is inversely proportional to area of a cross section. Let us come to the fourth point, that is about the temperature. That is about the temperature. Now you take one electric bulb. With the help of multimeter, you measure its resistance. For example, its resistance you got in this circuit. Okay. On the switch, allow the current to flow through it. Afterwards, you measure the resistance of this electric bulb, or you can say that you measure the, okay, that's enough. You can measure by the help of multimeter, we can measure the resistance of this electric bulb. For example, we got 3 ohm. What happened? Same electric bulb, we found the resistance when it is in open circuit 2 ohm. Now it is 3 ohm. The thing is that when we allow the current to flow through it for a certain period, that time the filament got hot. The temperature of the filament increased. Due to increase in temperature of the filament, we found that its resistance is increased. Then what we will analyze? We will analyze that when temperature increases, the random motion of electrons also increase. When the random motion of electrons increased, the number of collisions among the electrons or among the electrons and positively charged particle ions increases. As a result, as a result, the resistance also increases. So these are the 4 factors which affect the resistance. One is the nature of the material, one is the length of the resistor, you can say, one is the thickness or area of cross section, one we discussed about the temperature. Now let us come to our final point, that is regarding specific resistance or resistivity. Specific resistance, resistivity. Children, if you wish to learn properly, systematically, consistently, you have to subscribe. Simply 1 minute watching, nothing will happen. You can't turn the world. So, if you are sincere about your study, try to listen carefully and study sincerely with consistency. 1 minute watching video, second minute, next moment you are roaming here and there, no result. So I hope that you will subscribe and share this video. As a result, your friends can also get the benefit. Let us come to the topic. Specific resistance or resistivity. So, experimentally, we found that R is proportional to L. Just I said, R is inversely proportional to area of cross section. If I combine these two equations, then I can say that R proportional to L by A, or I can say that R equal to rho into L by A, or I can say that rho equal to R A by L. Sorry. Listen carefully. This rho is called specific resistance, or it is called resistivity. Rho is called specific resistance or resistivity. In this case, rho can be equal to R if A will be 1. So I can say that specific resistance or resistivity of a conductor is equal to its resistance of unit length and unit area of cross section. I can write it. The specific resistance is the resistance of a conductor of unit length and unit area of cross section. That means if both area of cross section and length are unit, then the resistance of the conductor will be its specific resistance or resistivity. So we got that R equal to rho L by A, or I can say that rho is equal to R A by L. Then what is the SI unit of a specific resistance? So for R I can write ohm, for area of cross section we can write meter square, for length we can write meter. That means it is ohm meter. This is the SI unit of a specific resistance or resistivity. Okay, children? So specific resistance, or I can say resistivity, it is one of the characteristic property. It is one of the characteristic property. If it is metals, its specific resistance is very low. In case of metal, it is very low. I can say that it is 10 to the power minus 8 ohm meter. If it is semiconductor, it is 10 to the power minus 5 ohm meter. But in case of insulators, it is very high. It is very high, 10 to the power 13 ohm meter. Listen carefully. For metals, it is 10 to the power minus 8 ohm meter. For semiconductor, it is more than metals, 10 to the power minus 5 ohm meter. And so far as insulator concerned, it is very high, 10 to the power 13 ohm meter. So I can say that the specific resistance or resistance depend on its temperature. It increases for metals, decreases for semiconductors. Okay. So for alloys like tungsten, like manganese, the temperature effect is very low. So this is about the specific resistance and resistivity. So in this video we discussed about the ohmic conductors non-ohmic conductors, factors affecting the resistance, and also we discussed about the specific resistance or resistivity. Can you say what is the reciprocal of a resistivity? So definitely I can say that the reciprocal of a resistivity is conductivity. Previous video I said reciprocal of the resistance. Now I am telling reciprocal of the resistivity, which is called the conductivity. This is conductivity. Okay, the reciprocal of resistivity is called the conductivity, and its unit what I write 1 ohm meter, or we can write like this way, or you can write like this way. So this is today's videos. Next video we'll do some wonderful numerical problems, because most of the comments coming from my students, they're asking, sir, you are not preparing numerical videos. Actually my target was the end, but anyhow some portion already we have completed. Next video definitely I shall bring some numerical problems. Which one will give the more benefit? No doubt at all. Thank you. Jai Hind.